first of all, you see, you either have Boltzmann distribution written or Maxwell Boltzmann distribution written is the same thing, okay? So do not be worried about this at all. Now, over here, this is the graph that you need to know about it, okay? So look, this red line over here is telling you the normal peak, okay? All right, this is at the normal temperature, all right? And this entire area under the normal, okay, is telling you how many particles are present at particular kinetic energy, okay? So, for example, let's say if we number them, okay, all right, and this number is, let's say, representing the speed of the particles, okay, all right, let's say meters or centimeters per second, like that, right? Okay, so imagine at 2 we have this much particles, okay, and at 6 we have only a few particles, right? Okay, now tell me, if I will lower the temperature, okay, so what will happen? For that, we have to look at the blue graph over here, okay. So this is the lower temperature over here. Let's say I label it as T1 or it can be labeled as T2. Now in the exam, you have to follow the instruction according to the paper, okay. If the examiner is saying this is T1, you label it at T1, okay. If examiner is saying it's T2, you label it as T2, okay. Okay, so now look, when the temperature is lowered, okay, the kinetic energy decreases of the particles, right? Okay, and because of which at a lower number we have higher amount of particles now present. Are you getting that? So earlier, if I compare to the red one over here, okay, earlier at a lower temperature there were less particles, okay, but now since it's colder, so the quantity of the particles that have lesser kinetic energy have increased, okay. Now if I look at this one over here at 0.6 over here, okay, so you see the number of particles that have a very high speed has decreased right now. Are you getting it? Because of which, as compared to the normal, the graph has gone high towards the left side and the graph has gone low towards the right side. Got this, everybody? Okay. Now everybody, we are looking at the other graph over here, that is the green graph over here, okay. The green graph is representing higher temperature. Let's say we are labeling it T2 over here, okay. At a higher temperature right now, that means the particle's kinetic energy will increase or decrease? Increase, very good, okay. So as the kinetic energy will increase over here, okay, so what will happen is this, the amount of particles, okay, having a 3 or 6 kinetic energy, they will increase, they will be the highest over here. Are you getting that? Huh? If you look at the 3 over here, okay, so they are the highest over here, okay. So eventually you see over here, okay, you will find that these have the highest quantity or highest number of the particles are falling in that category over here. Are you guys understanding that? Okay. Now guys, we are talking about activation energy, okay. Can anybody please tell me what is the definition of activation energy? Yeah. You know. Okay, so activation energy is the minimum amount of energy needed to start a chemical reaction, okay. You have to remember this forever, and EA, okay, is the symbol for activation energy, okay. So let's say over here I draw a line and I say this is EA over here, that at this point we are representing that the particles have achieved enough activation energy in order to collide and in order to react, okay. Now imagine, I'm repeating it for you all first of all, okay. So imagine there are 1,000 particles over here, okay. So with the blue one, okay, they are representing that it's a higher peak over here. That means let's say 800 particles are present at the very lower energy, because of which it is like that, okay, like the tallest peak over here. Don't go the tallest peak has the highest temperature. No, the tallest peak is representing over here that this is the highest amount of particles having energy which is very, very low, okay. Now when we look at the normal temperature, okay, now those 1,000 particles have distributed throughout, okay. So that means this much particles that were there under the curve of blue, now this much particles have spread it out throughout the red curve. Are you getting that? So the number of particles are not changing, okay, only their distribution is changing, okay. So if it is going down over here, you should acknowledge that it is going up over here as well, the red line. Are you getting that? So the 1000 particles are spread throughout. And when we talk about the higher temperature over here, okay, so over here it went even down over here, okay, and it went even up over here because now they are redistributed even more towards the higher kinetic energy. Activation energy is represented by EA. What is activation energy? Activation energy is the minimum amount of energy needed to start a chemical reaction. This definition you should memorize by heart as well, okay? Alright, now activation energy, imagine there was a certain reaction, okay, that was happening at 2000 degrees Celsius, okay? So now my question is that if, let's say, I add a catalyst, okay, where the activation energy will shift, would it shift over here or would it shift over here? Okay, so if your answer was this, that it would shift over here, so this is correct, okay? So this one we will label it as EA cat. That means this is the activation energy with the catalyst. And now if a reaction earlier was happening at 2000 degrees Celsius, now this reaction will happen at 800 degrees Celsius, okay? So that means now the temperature needed to do a chemical reaction has been decreased. Now if you look over here, more amount of the particles are able to react successfully, right? Okay, because what is activation energy? Minimum amount of minimum amount of energy needed to start a chemical reaction, okay? Why are they, like, how are they starting the chemical reaction? As they are providing enough energy for the molecules to collide with each other and to react with each other, right everybody? All the best.